All right, so I've created an assignment in ALEKS that will, I think, help you progress with the proofs. I know a lot of you guys are running into proof problems, and it's been a while. You know, we did proofs at the end of Integrated 1, and depending on the teacher you had, maybe you did more proofs than another class because proofs are very difficult to teach, and sometimes teachers feel more comfortable and more capable at making proofs clear, so they really address them, and students make lots of progress. And other people are like, I have a hard time making them clear, so they kind of steer clear of proofs. But anyways, besides, whatever your situation might be, I think you can do this. I know you can. And so when you look at a proof, here's the given information, here's what we're trying to prove. All of these things are going to be down here in the proof. So we could scan through, and see if the given information is anywhere, right? So here is the given information right there. That would be an easy one to pick. 2 and 4 are equal to each other. Hey, there it is right there. I personally always put the given at the very top of my proof. So when you're allowed to choose what order to put them in, I would send that to proof right away, the given information, okay? Now this is going to be your last line in the proof. Angle 1 and angle 3 are congruent. So if we look down here, see how that's the last line of the proof? So what we need to do is look through the way that the author tried to prove that 1 and 3 are equal to each other. So I believe that we should brainstorm a little bit. That's our goal, right? To get 1 and 3 equal to each other. Well, what do we know? 2 and 4 are equal to each other. There, 2 and 4. And the whole angle QYS is equal to the whole angle up here, TXV. Now your common sense might be going, well, of course, like if 2 is, let's say, 20 degrees, 4 is 20 degrees because they're equal to each other. And let's say the whole angle is 50 degrees here. Well, the whole angle down here is 50 degrees because they're equal to each other. Well, if we took 20, this is 20 right here, right? If we took 20 away from 50, that'd be 30 for 1. And if we took 20 away from 50 up here, well, it's 30, right? So we're going to subtract in some way to get angle 1 and 3 equal to each other. So we look down here and we try to figure out what the author was doing. The author's trying to say that the bigger angles are made up of the smaller angles. That's called angle addition property. So you're looking, like you see addition over here. So look for something that says addition, right? Now, I think there's an angle addition property. That might be a little tricky, right? For a beginner or somebody that's forgotten just about everything there is to do with proofs. Think about what they're doing up there. They're adding angles together. So I think this is going to be the most reasonable one, angle addition property. And then here we already said given, right? So we know these two are equal to each other. Well, we could set these two now equal, like this whole expression on the right side equal to each other because of substitution. We're substituting in 1 and 2 for this guy and 3 and 4 for that guy. So I'm looking for substitution in here. Let's see, you just scroll around. Oh, here it is. There's not much to scroll through. And then 2 and 4 are equal to each other. Well, how would 2 and 4 equal? Oh, that was given, right? And then we're going to substitute in instead of having a 2 right here. So we're trying to compare, like, how do the lines up here change to become these lines down here, or this line down here? Well, this line right here has definitely been modified, right? How has it been modified? 2 is now 4. That's called substitution. So we're going to use that one again. And then we're going to, let's see, how would 4 go away? Like from this line down to this line, there's no more 4, right? Well, we're going to subtract. So we're looking for subtraction. Do you see it? Oh, yeah, addition and subtraction properties. All right, so I think that's it. If I check it, let's see if I get it right. Hey, did it, okay? Now, you might not have a proof exactly like that. Yours might be a little different. On number 2, I'm pretty sure everyone's going to have something about alternate interior angles and corresponding angles. So let's review that real quick. Alternate interior angles are like 4 and 6, 3 and 5, because they're interior of the two lines that are kind of parallel. They don't look parallel to me right now, but they're in between these two lines, and then they're on alternate sides of the transversal. That's why they're called alternate. They're on alternate sides, like 4 and 6 are alternate interior angles. Okay, so 4 and 6, or you could have put 3 and 5 there. And then corresponding angles are angles that are in corresponding locations. Like, see how 4 is on the right side and it's below the transversal? 8 is on the right side of the kind of the vertical line and below the transversal. So I'm going to say 4 and 8 right here. There's other options. Do you see a couple other corresponding angles in there? How about 3 and 7, right? How about 2 and 6, 1 and 5? Those are all corresponding angle pairs, if you will. They come as pairs. Alternate interior angles come as pairs. Corresponding angles come as pairs. Alternate exterior angles come as pairs, like they're on exterior of the two kind of vertical lines. So like 1 and 7 are on alternate sides of the transversal, and they're outside the parallel lines. That's why they're called exterior, because they're outside them. And then alternate of the transversal. All right, they always come as pairs. Do you see another pair in there of alternate exterior angles? How about 2 and 8? All right, so here we go, 1 and 7. Now, the alternate exterior angles are congruent, the corresponding angles are congruent, and the alternate interior angles are congruent pairs if the lines are parallel. Now, these lines don't look parallel to me, so you notice how they're not asking us to say that they're equal to each other. We're going to do that. We're going to use that property, on some of our problems ahead, okay? All right, well, here it is right here. We're going to use that property, right? So let's see, they say 8 is 148 degrees. Let me try and do a little writing on here, because I really feel like these proofs emphasize the idea that if you put a drawing down and you write on the drawing, it makes your life so much easier. That's probably the main reason I like proofs. Like, as soon as I put 148 in here, I can say, well, this is 148 over here. My brain says, oh, hey, those are alternate interior angles. And if this is 148, this is 148 over here, right? So, I've got my answer right here, 148 for angle 2, without really stressing my brain very much. Now, these two are called a linear pair. See how they're adding up to be 180 degrees? Or these two right here, 4 and 3, or 2 and 3. So what's going to get us to 180 if we're already at 148? Well, I think that's 32 more, isn't it? So 32 for that one. So some of your homework problems tonight are going to be that easy. If you remember a lot of this stuff, it's going to be real easy. If you've forgotten everything there is to know about parallel lines, alternate interior angles, all that stuff, it's going to be a little bit more of a struggle. These are called same side interior angles, right? They're supplementary. All right, so let's get out of this, and let's see, I want 148 and 32. Let's see if I get this right. 148 and 32. So 148 and 32. All right. Hey, ladies and gentlemen, I'm just going to walk around after you're done with your test. Please finish as many of these as you can. Thanks for following along with my video. Appreciate it.